Hey everyone, welcome to the AWS Developer Workshop Theater. Thank you very much for joining us. We have another excellent session from Alex. You might have seen him present on AWS 101 this morning. Also, hello to the couple thousand of viewers out there on Twitch. Thank you for tuning in. Very glad that you could join us. So Alex is going to take an existing Express JavaScript application, and he's going to port it over to serverless architecture. So if you've done any JavaScript and you want to learn how that might apply to serverless, you're in the right room. So thank you very much. Alex, take it away.
Thank you, Brandon. Hi, everybody. Welcome back. How many of you already attended the session today? Not too many? Cool. So welcome for the first time to the theater. Thank you, all of you on Twitch. We had so many good questions, so keep them coming. And I'm here. We are here all day, today, tomorrow, and Thursday. So keep your question coming. We are happy to help. So yes, this session is about porting an actual application in about 30 minutes. We have 45, 50, so I can do some introduction and get you started on serverless computing and some of the main concepts that you may not be aware of. I'm a technical evangelist. I'm a software engineer and web developer. That's mostly what I do, what I've done in my career. Now I'm a technical evangelist at AWS. I also organize some serverless events around the world. We call them serverless days. We haven't had one in Canada, but it's probably coming soon as well. So if you're interested, just reach out. Happy to help there too. The agenda for this session is a little bit of background about serverless computing. What is it? When and how and why does it make sense? Then I'll do a brief introduction about which programming language you can actually run on AWS Lambda, our serverless, and the rest of our serverless platform. And then we'll actually do some live coding and there's app migration. I've actually have a very similar app and a very similar demo for a Python web application. So if you're more into Python, okay, who is a JavaScript developer or does JavaScript? What about Python? Okay, so JavaScript wins, sorry. I could have done it in Python, but come to me, I can share the Python version with you. So sorry, the last time you raised your hand, how many of you already know or are familiar with serverless computing? A few, great. So for all the others, and for everybody actually, why serverless computing? What does it mean? When and how does it make sense? First of all, what do we really mean when we say serverless? Because a lot of people I meet around the world tell me, well, there are still servers, right? It's not that we hate them or that we want to not use them. It's that there is a lot of work involved with managing and patching and provisioning and thinking about servers or containers in general. There is some heavy lifting there. There is some maintenance that needs to go on. Even the skill set that you need, it's a mix of operations, ops, DevOps, and so on. So when we say serverless, when you do serverless, you might actually use more servers than people that actually use servers because we manage them for you. We spin up a lot of machines, virtual machines, and instances for you under the hood, of course. It's just that you don't have to think about them at all. They kind of disappear from your development workflow. And the consequence of that are a few consequences, a few benefits. First one is you can be much more flexible as far as your scaling or the scale of your application, because all you need to provide is your application code, your business logic, everything under that, as we talked this morning in the first session, everything below that, we handle it. So all the networking, all the virtual machines, or the patching of the operating system, all the security of that part of the stack is on the cloud provider, on us. So it takes, first of all, some heavy lifting off your workload, your development workflow. But it also means that you can scale much, much faster. If you have 0 calls per second, or if you have 1,000 calls per second, it's not your problem, it's our problem. We take care of that for you. And it's elastic, meaning that if there is nothing going on, 0 calls per second, you pay 0. Okay, that's the idea. Instead of paying per hour or per month or per second, you pay per 100 millisecond intervals, right? That's a big mental shift when you think about developments or cloud resources in general. And that's how this serverless revolution kind of started in 2014, 2015 when we announced AWS Lambda, which is our function as a service offering. So the idea they can go up to potential infinity and down to zero based on the current load. It changes how you build software. It changes how you think about architecture. It's changing how you think about your business model as well. So there is a lot of things to think about. Today we talk about the technical stuff. So another consequence is that the availability of your application, the resiliency of your application, that's also on us, right? Meaning we take care of deploying your application into multiple data centers, so that if anything goes down, even if the whole building goes down, your application is still up and running. That's something that if you use traditional service, you need to take care of that somehow, and you have the skills and the time and to pay those people that do that in your organization. It's a lot of time that you can invest otherwise to not reinvent the wheel, to build something that brings value to your customers for real. And so that holds for security, that holds for resiliency and availability as well. So this is about benefits in general, and with a live demo, I'll show you how to actually do it and what really changes. Another advantage or another shift that we see is that you can now finally build event-driven architectures without thinking about the servers. So event-driven because everything in the serverless world is an event. Okay, something happens in your AWS account or in your cloud environment, a new object on Amazon S3 or a new record in your database or a new user logs in. You can think of that as an event that triggers your Lambda functions. And your functions are stateless, and they can just react to these events, maybe call some other services or stored the information into another database or do all sort of business logics that you need to do. Even an HTTP call is modeled as an event. So if you're handling HTTP calls for your APIs, for your backend, for your web or mobile applications, those are also events coming into your function, and your function will always get this event object as input, and it will come back with another JSON or, depending on the language, another kind of output document. If you are doing APIs with a body and a status code and everything, we'll see that in a second. The use cases, if you ask me about a year or two ago, I started doing serverless around 2016. I would have told you maybe 40–50% of the applications could have been built on top of AWS Lambda and with a serverless kind of approach. If you ask me today, I would probably say more than 80 or 90%, because we have added security functionalities, compliance for credit card payments, like ISO or HIPAA, and all sort of certifications. We have augmented, enlarged how many minutes your Lambda functions can run with. So from 5 minutes up to 15 minutes, so that covers a lot more use cases now. And the number of integrations, there are more than 40 or 50 integrations from other services that you can use, not only to handle these events, but even to customize how the other services work. Let me give you an example. There is a service called Amazon Cognito User Pools that allow you to manage users, like sign in, sign up, password forgotten emails, or multi-factor authentication, everything about users, so you don't have to re-implement it. But you can extend the behavior of that service using AWS Lambda hooks. So you can say, on sign up, run this function. Then you can implement whatever you want in whatever language you want as an event. A new sign up happens, go and send an email, go and store a message somewhere, really do whatever you want. Or when the user requests to change password, okay, run this other function. And you can kind of customize the built-in functionality of this service using Lambda. And this is happening in a lot of places. And this is actually something that a lot of other customers are doing for their product. If you have a product and you want your customers to customize the way your product behaves, you can do something similar. Use Lambda. You allow them to provide code to you to extend your system, and you run their code on Lambda. That's what we're doing. That's what a lot of customers started doing as well. So you can let your customers be event-driven and customize the behavior of your application. But anyway, the use cases go from web app, backends for web application, IoT, even chatbots. How many of you have an Amazon Alexa at home? A few. I have a couple. So Alexa is built on top of AWS Lambda itself. So every time you say something, the request goes to an AWS Lambda function, and you can just code what needs to happen, what's the response, what to store in which database, and so on. So the idea is that everything that's driven by events or by user interaction, or everything that has a very spiky or unpredictable load is a very good use case for Lambda, so that you're not over-provisioning or under-provisioning. If we have 10,000 requests from 0 to 10,000 requests per second in half a minute span, that's really hard to handle with the traditional instances or containers because you need to scale really quickly. Lambda can scale in less than a second. In a few hundred milliseconds, we can spin up thousands of these micro virtual machines to handle your requests. There is even a spatial way to define your application structure, let's say, and we're going to use that in the demo, so don't worry. If you know what Amazon CloudFormation is, that's how we do infrastructure as code. So you define your application as a template, and that allows you to deploy your application to multiple accounts, multiple AWS region, or multiple environments like development, staging, production, and so on, without touching anything. You just deploy that template. And AWS SAM, besides being a cute squirrel, it's also the serverless application model, and that allows you to define serverless application with that same approach, but with fewer lines of code. It's also open source, so your template from this, like maybe a couple hundred lines of code, becomes 20, 25. So you can define your functions, your APIs, the events that invoke them, and all the other resources in a template. So that's how you define a function. Okay, whatever. So you define this AWS serverless function resource in your CloudFormation template. You specify which events can invoke it. Eventually, you provide some permissions, so your function can do this or that, because by default, your functions cannot invoke any other AWS service. If you want anything to do anything, you need to provide permissions, because it's secure by default. It's locked down to just running stateless code. If you want to read from a database or write into a queue, provide permission to do so. And with 3-4 lines of YAML, this is YAML code, but you can also use JSON. With 3-4 lines of YAML code, you can provide those permissions. There is even a local tool that we call AWS SAM CLI that allows you to emulate AWS Lambda, API Gateway, and some of the other related serverless on your machine. So you don't necessarily have to deploy everything to the cloud. If you are offline, or if you have some unit tests or integration tests that you want to run locally, you can do that as well and emulate all this environment on your machine. This is also open source. So let me tell you a little bit about the runtimes. If you're using Node.js, that's been one of the very first languages to be supported by AWS Lambda, but there are basically every other language right now can be supported. And let me tell you why and how we got there. So we started with Node.js back in 2014, 2015. We also had Python 2 and Java. That was the first 3. And that's when I started. Basically, I could use a couple of them. Then we added Node.js 4, .NET. We keep adding more Node.js versions and Python 3 as well. And then last year, we had this boom of new runtimes, a new programming language that you can use on top of Lambda. And that happened, well, first of all, because customers ask for it, and that's what we do. If you ask us to do something, we have enough customers saying so and requesting a given runtime or a specific language or a feature, we try to deliver as soon as possible. But also we have released a new feature of Lambda, which we call custom runtimes, that allow you or anybody to come up with their own custom support for other languages. So other partners and the community has been building support for PHP and C++ and even COBOL. We have a customer who migrated their mainframe code to AWS Lambda with this COBOL runtime. So you can kind of containerize or reshape your application code to run on Lambda, whatever language it is. There is no kind of excuse anymore. And yeah, we recently, like a week or 2 ago, announced Node.js 10 support too. But how do you actually choose the right language? I mean, do you really have to? I've seen teams using AWS Lambda and implementing different endpoints and different parts of the system in different programming language. That's one of the great advantages of building microservices. You know, each sub-part of the system can be independent. We'll use a different database. Potentially, we'll use a different language. So I'm good with Python and Node. Maybe you're very good with .NET and Java, or my friend is very good with Go for some other sort of use cases. So we can all work together in the same system, and every function can be implemented in a different runtime. So that's pretty flexible, I think. There are reasons why you may want to choose a specific runtime. If you want to do a lot of things in parallel, it's not recommended, but it's probably easier to do it in Node than with Python threads or something like that. So depending on that, you can choose the favorite programming language that you like, or the one that's specifically built for that kind of task. So how do we port a web application? There are a few strategies. Let me show you a couple of ways that we can cheat, kind of take an existing app and migrate it, like lift and shift it to AWS Lambda without touching it much. So if you're using Express specifically in Node.js, there is actually a library called AWS Serverless Express that kind of wraps your application and makes it serverless ready. It makes it compatible with AWS Lambda. And you can keep using your middlewares and your libraries and your application code without really almost touching nothing. It's open source on GitHub. You can go and try it out. Why not, if you're an Express application? That's not what we're going to do today, because it will be very easy and kind of cheating. There is a Python version of that, actually 2 versions of that, if you're using Python and frameworks like Flask or Django, for example. So there is Zappa. Zappa is another library that kind of wraps your Django application and also makes it kind of serverless ready. So what you do is you install it, you init, and then you deploy. It will just detect your Django app and deploy it to Lambda as is. Maybe you configure the bucket where the code needs to go, but there is really no code change. And of course, some Django plugins are supported, some are not. It's very well documented, and it could be a good way to get started and lift and shift your app. It's also open source. There is a second version of it. If you're using Flask specifically instead of Django, there is Chalice. So Chalice requires some code refactor. So you install it, you refactor a little bit in your code, and you Chalice deploy from the terminal. So the refactor, this is a typical minimal Flask application. The refactor is really about that. Okay, so you kind of just change the library. Instead of importing Flask, you import Chalice. Everything else is supposed to work. And again, the Flask and Django ecosystem is so big that some of the plugins, some of the hacks or workarounds are not fully compatible with this. It's a lift and shift approach, meaning it probably works, but it might need some fine tuning. But it's a good strategy to see how your application delivers as far as speed and performance and security in a serverless environment. So check it out. It's also open source. This is not good enough. Okay, we want to actually optimize our code for AWS Lambda. We want to make it fast. We want to make it cloud ready and cloud native. We want to add all the security, permission policies so that our functions are doing the right thing. And we also want to optimize for performance. That's a big difference if you go for these lift and shift approaches, because they end up doing a big, fat AWS Lambda function that does everything. It's like a new monolith, but it's shaped like a function. The consequence is that the amount of code that you need to upload is pretty big. It could be 20, 30, 40 megabytes. Okay, that's not the optimal way to do this. The idea is to have at least the least amount of dependencies, the least amount of code to reuse, managed services and to use what Lambda comes with by default. Like you have the SDK and you have some built-in libraries depending on the runtime. So if your code, if the deployment package that you build for Lambda is, 50 kilobytes instead of 50 megabytes, as you can imagine, we have a lot less stuff to move around. And even for you in the developer experience, it's much faster to upload 50 kilobytes than 50 megabytes. So we can do better, and let's do it. So I have this GitHub repo. There is also the Python version. It's on my GitHub account. So let's go and open it and see what we can do with that. If internet is up again. Yes. So I've actually forked this application from an already existing one. It's an Express application. It used to run on Amazon Elastic Beanstalk. So there is already some AWS configuration in there. Again, I'm trying to make it a bit easier and faster so we can do it in 30 minutes. So it's already running on AWS, but not on Lambda. It's running on another compute platform that's using instances and kind of containers, kind of abstraction level. So let me actually show you. It's a simple startup landing page. So it's a landing page that's showing you, hey, we have a new product. Do you want to sign up for it? There is a form, a module. You sign up with your email and a couple of more fields, and we store that data into a Dynamo table, and I get an email whenever someone new signs up. Very simple use case. It does only one thing. But let's see how we can migrate that to serverless quickly. So I already have the code on my machine. So let's open it in an IDE. This is what the app looks like. There is an app folder with one index.js file in there. There is a lot of stuff related to Express.js itself, and we are going to remove all of that. So the amount of code that we end up with might be like 50% of what we started from. There is also a static section, a static folder, and there we have JavaScript resources and CSS and JS stuff. This application was doing some server-side rendering to render the HTML, and it's doing that, with the typical Express format. So there is stuff like static path and variables in the templates. So the first thing we want to do is to do, to follow the modern application best practices. So web application. So we want to separate our front end from our back end. So our back end can scale independently, and our front end can be a simple, let's say simple, static website that can evolve independently from the API. So the first thing we'll do is converting this dynamic template into a static HTML file. And we could even take that into another repo and give it to another team, and maybe they start using Angular or React or Vue.js, and it'll be their project as long as we agree on the interface. So first of all, let's move this file to the static folder. So what we're going to do is to have everything that is a static front end in the static folder, so we can deploy that to Amazon S3 as a static website. So let's move it there, and once it's there, we can simplify it a bit. Actually, it needs to be in another format. So it will be static index.html, so we can deploy it easily. So now that it's an HTML file, we're going to remove all this dynamic content here. We can just simplify a bit. This might be converted into a static website generator or into environment variables if you're using React or Angular. So let's not spend too much time on that. We can use the default theme, like default. We remove all this stuff that's dynamic. So I'm not saying this is a required step for you, but this will help you separate these two different applications, your front end and your back end. So let's remove this stuff here too. Anything else? Yeah, okay, we can get rid of that. Cool, so we are left with really just a static website here. There is some jQuery logic to take the input form and to submit that to an API. And as you see, there is a /signup endpoint that we are posting our content to. And of course, as soon as we separate backend from front end, our static website and our API will probably not be on the same domain or the same origin. So we'll probably need to change that /signup and actually add the API domain there, like my company / whatever. But for now, let's take that static website and deploy it. How can we do that? Okay, so I already created an S3 bucket for this. Let me find out what's the name. It should be like serverless signup. So we can do the static website deployment with one comment, and that's pretty easy. Let me find the bucket. So this is the S3 console, and I already created this serverless signup bucket for us to use. I'm going to use that. And how do we deploy this static folder into S3? That's as easy as AWS S3 sync static, and then we do just that. Okay, this way we're just syncing the local folder with the remote bucket, and everything will be copied. Every time we change something, just sync, and it will go just like that. But this is a public website, right? We want everybody to be able to access it. As I mentioned before, you need to provide the permission for this file to be read. Otherwise, by default, the cloud is secure by default. So if I just upload them, nobody will have access to it. So we just do ACL public read. Okay, this makes sure these files are readable from everybody out there. So let's do that. And this command is now reading the local folder, reading the remote folder, finding the differences, and uploading the files. So if I did everything correctly, I should now be able to open the static website of this bucket and see my application. Okay, so I told you it's a very simple application. It's a pretty ugly web page, but I can do sign up now, sign up today, and here I'm shown name, email, and a couple of parameters like, do you want preview access? Yes, no. It's super simple, but of course, if we try to sign up, we get a beautiful 405 error, which is like, hey, you cannot post into an S3 bucket because we are using this domain, and this domain is a static website. You can't really post to it. We need to create the API to take the data and save it into a database. So let's do that. First of all, let's see what the application code looks like. It's a JS file. There is a lot of stuff going on. The first part here is about handling multi-process, your multi-process web server. We don't really need that anymore. So I'm just going to delete this first part in here. There's already 25 lines of code. We do not need to write. We do not need to maintain or patch or test or debug. Done. So everything else here is business logic, more or less. There is some more server listening, port configuration. We don't need that either. So everything here that is left, if we remove the application setup, we don't need that. If we remove the HTML view that we used to render with Express, we don't need that because now the website is static somewhere else. So that's also not needed. So we already ended up with about 50 lines of code instead of 100. And let's see how we can make this AWS Lambda compatible. We actually don't need these two dependencies either. Okay, we are good. So now the shape of your Lambda functions, the handler of your Lambda function should take an event parameter and a context parameter as input. So let's do that. Exports.handler. We have an event variable and a context variable. Okay, I'm using the new ECMAScript 6, 7, whatever. So in this event, we're going to receive the actual input event. In our case, it will be an HTTP call. So we have the body, the headers, and everything in the HTTP request. The context is useful for like, who is the identity, how much time I have left, and all sort of contextual information there. So is this compatible with our Express interface? Express give you request and response. So it's not compatible. We need to do some refactoring there. So let's do that. So our body will be JSON parse event.body. So event.body is the body of the request, and that's a string. So we JSON parse it, and we're going to have the body of the request. That's one line of code, and then we can use body instead of request.body everywhere. Okay, done. So the business logic here is just creating a DynamoDB item. That's just a kind of a JSON item with some string. We are storing 4 strings here, and we are taking that from the body of the request. We might want to have some validation, but we're just porting here. We are not improving or adding new functionalities. Let's just focus on the porting. So what comes next? We are putting an item, we are writing into Amazon DynamoDB, which is our NoSQL database managed for you. And based on the result, if everything went all right, we're also publishing a message into an SNS topic. It's our simple notification service topic. And when that happens, we'll get an email because we have configured SNS to send us an email whenever there is a new message in the topic. So this is a bit unreadable. There's a lot of callbacks mess in there. So maybe let's reshape it a bit to be, to use async await and to be a bit more modern. So we are kind of, modern, let's say. So we're just doing await. And instead of this ugly callback, we are just doing a try catch maybe. So it's a bit more readable. Cool. So we catch the exception, the error, if it happens. So all the error handling logic can just be moved here. Cool. And then we can take our SNS publish code just here. We do await. That. We actually need to do .promise. Otherwise, it doesn't work. We can just promisify the SDK calls. So we have a promise, you can await it. We'll do the same here. Great. So we'll do another try catch here. I'm just doing some code refactoring and modernization, but we don't really have to do this for Lambda. I think it's just fun. Let's do it quickly. So if it is an error, we want to give a 500. Otherwise, we want to give a 200. Okay, I'm still using the response variable, so that doesn't work, same as the request. So the contract between AWS Lambda and API Gateway, the service that we are using to have a RESTful interface on top of our Lambda function, is that we should return an object that is shaped like this. We should have a status code like 200, and we should have a message. This is, we should have a body, which could contain, in our case, a message, and it could be anything. That's the structure that should be the output of our function. So let's create just a little helper to do that. So we have status and message. Sorry, I'm really bad at typing on stage. I'm getting better. So that's what we should return. But yeah, let's use those. And the message. Cool. So we have now a nice little handler that returns the response that the API Gateway expects. So let's just do it. Down here, we wanted to return a 500 with a KO message, whatever. And maybe we also return, and maybe we console log. So I didn't mention so far, but everything you log in a console log or in a print, depending on the runtime, goes to another service called Amazon CloudWatch. There you will find all the invocation logs, all the prints, all the console information of all your invocations. What happens when we have a 200? Well, actually it's a 201, and we say OK. And we also have another case up here where, so this is a bit different, because if DynamoDB fails, it might actually be that the email that we are trying to add already exists. So we want to handle that case, and instead of 400 or 200 or 500, we want to give a 409, which means like object already exists, so the client knows that it's not an error, it's just that it exists already. So let's just use the return status. It's still a KO in my opinion, but we can argue about that. And let's move the console log up there. So in our logs, we will see whether it's a DynamoDB error, whether it's an SNS error, and we have configured input and output to use the AWS Lambda convention. So we ended up with 60 lines of code. Are we good? Yeah, syntax is good. So up here, we didn't spend too much time talking about what's happening here, but here we are just reading the environment variable from the process.env, and you could do the same in Python, in Java, in Go, in .NET, just by using the operating system environment variable API call. So we are reading the name of the table and the name of the SNS topic from an environment variable that we can configure. Cool. So our code is being ported. We're not done yet. The code is there. We can deploy it. But again, we want to apply the best practices, and we want to do infrastructure as code. We want to create a nice little template for our developers or DevOps or operation people to just take that and deploy the function without having to redo everything manually in the console. So let's do that too. So what we want to do is to create a new file called template.yaml. It could be called any way you want. Template.yaml is a convention. And it could be also JSON, by the way. For those of you that prefer JSON over YAML, who prefers JSON over YAML? Sorry. Did you know that YAML is actually a superset of JSON? So you can use JSON inside YAML. That's just random knowledge. But if you have a JSON template, you can just throw it inside a YAML file. It works. Trust me. That's why I prefer YAML, but I'm sure you have your ideas and your your reasons. So now we have this YAML file that we can use to define our application, right? So I have a really, really bad memory. So let me go and find what's the structure. It's all pretty well documented. So the serverless application model that I've mentioned before, it's on GitHub. You can find all the documentation about how to define your applications. So let's take the sample template from there and start from there. OK, so that's the typical sample template that we are starting from. Let's use that. So what are we doing? We define, OK, this is a template. We are applying a serverless transformation. This is what AWS SAM is. It's a transformation, so our resources will be transformed by CloudFormation, but don't worry about that, it's just a detail. And then we define our resources, okay? We have our sign up function. We could name it, this is just a logical name. We could name it any way we want. And we define this serverless function. We want to define where the handler is. So we define the app folder, and we have the index.js file, and the handler is called handler, right? So we are just defined where the code is in our folder structure. Then we define the runtime. Let's use the Node.js 8 runtime. And then we have a few more properties to set up because we want to have an API interface on top of this function. So let's go and find that. Yeah. So when you define a function, you can have a property called events. So we need a list of events here. And when you define events, let me find that. You can have different type of events. So if it's an S3 event, like a new object in the object storage, SNS, Kinesis, Dynamo, there are like a lot of them. These are the ones that AWS SAM supports. Today we want to use an API event because we are building an HTTP endpoint. So that's how you do it. You give it a name. It could be post event. So it's of type API. The property is /signup, like we had before. And it's a post method. It could be get, put, delete, whatever you want. So we have already configured the event that we want to use when invoking this function. And AWS SAM will just take this and create all the resources around it. The API gateway API, the resources, the methods, the binding between API gateway and Lambda. So this is doing a lot of stuff for you. You don't really have to learn it, but it's doing a lot of stuff for you. What else? So we need some permissions. Why? Because this function is actually writing into a database, and it's publishing a message into an SNS topic. So if we don't provide permissions, as I've mentioned before, it's not going to be able to do that. So we need to provide permission. How do we do that? Let me find out. You don't need to learn to know all this stuff by heart, of course. Yeah, it's somewhere here. Yeah, so you have these policies property that you can use. So let's copy that, and let me show you what it looks like. So a policy, it's actually an IAM policy. IAM is Identity and Access Management. It's an AWS service that allows you to do who can do what in your AWS account. So when you specify a policy, you can either use a managed policy, like this AWS Lambda execute policy, that is the default, and then you can add more. So this is a list in YAML, right? So we can add more policies. So we're going to add 2 policies, one for DynamoDB and one for SNS. So we want to allow some actions on some specific resources, right? So the action that we want to allow is DynamoDB put item, because that's what our function is doing. And remember, you can be very granular. You don't want to give your function, I could have done this, but some butterfly out there will die, somebody will feel really sorry for you. If you do this, your function can create tables, delete tables, do all sort of things. You don't want that. You want to be very specific about what this function can do. So put item is good. And the same holds in the resource parameter. So we could say DynamoDB everything. So it can put item on every DynamoDB table, but no, it doesn't make sense. We want this function to write only in one specific table that we want to create for this app. So actually, this application already was deployed on Beanstalk, and there were some resource definitions that we can reuse. So let me find those somewhere. Yeah. So we have this table definition that we can use. So let me remind you what we are doing. We are defining resources in our YAML template, so we can deploy this with one click everywhere in our AWS regions and accounts. Here we can also add all sort of other resources. It could be our functions, our APIs, our database also can be defined here. So what I'm doing here is defining a startup signups table, which is a DynamoDB table, which has some properties. There is an email primary key that we're going to use. And what's the advantage of defining your DynamoDB table in the same template? What do you think? The advantage is that we can reference this DynamoDB table in the permission policy of our function. I can do something like that. So now my function can put item only on that table. And that table is created in the application stack whenever we deploy this serverless application. So we're going to do the same for our SNS topic. There is a bit more stuff here, but don't worry. I'll guide you through that. So we are defining a queue. This is an SQS queue. We are defining an SNS topic. And again, we are porting. We are not building a new app. Okay, this stuff was already in the previous application. It's not that you have to learn this to use AWS Lambda. We're just fine-tuning some stuff. Here I can say endpoint, like my email. This is my email. Don't spam me. And this stuff is just permission to integrate SNS and SQS. We don't need to go through it. But we want to provide our function with the permissions to publish a message into that SNS topic now. So allow, it'll be SNS publish, I think. Let me find out if it's true. SNS publish API. So whenever you are in trouble, you can just go and find out what's the name of your API resource patterns of your identifiers. So yeah, let me find that. That's right. So this is the name of the resource, and we're going to do that. Cool. And what's the resource that we want to publish to? It is this topic here. So we're just going to reference that as well, and it just kind of works. So we have just a few minutes left. So we managed to build kind of the whole stack, and we can start from this template and just deploy it to production or to a development account or a staging account. And the tool that we want to use is AWS SAM. So you can use SAM as a local CLI tool to take this template, and you can do SAM package and then SAM deploy 2 commands to deploy your application to the cloud. And this will take your code, create the deployment package, upload everything to S3, and configure CloudFormation to deploy your application. And with a couple more lines, you can deploy it to different accounts, different environments. You can configure environment variables, and so on. So I'd rather take a couple of minutes to answer your questions and instead of showing you the boring comments. So thank you for coming. If you have questions, I'm here. You can find this on GitHub. There is the same application for Flask and Python. You can actually get all the slides of today, tomorrow, and Thursday if we scan your badge at the booth or if you go to this public URL. So feel free to take a picture. We'll just send you you can sign up for the slides. Thank you. Sorry, picture. Thank you, everybody. And if you have questions, I'm here. Any question from you or Twitch?
One question for you. Most of the questions on Twitch were answered, but what do you think is the hardest part about transitioning to a serverless sort of architecture as a developer? What are the things that you should think about before you get started?
Right. So what's the hard thing about moving to serverless? There are a few things to be aware of. I think the hardest is the mental shift of moving away from your favorite full stack framework that you've been using for the last 5 to 10 years. And the challenge there is that these frameworks have been developed like Django and Flask and I don't know, there are many other for Java and other languages. These frameworks have been developed to work in a long-running server environment. They take sometimes 20 seconds to spin up and to be up and running, like Spring for Java, for example. But the mental shift is to get used to writing as little code as possible, to have the least amount of dependencies, to think about security, to think about permissions, to think about sharing code between your team. So there are other services that help you do that as well. But that's the mental shift that I've seen that is more like the friction when you start moving to serverless, and just not just taking the code and throwing it out on the other side of the wall, hoping somebody will deploy it. The idea is to shift to a microservices approach, DevOps approach, where you also own the applications and the service that you're building. So that might be the hardest thing. On the technology level, it's not that hard. So I think it's more of a cultural, mental shift. Thank you, everybody.
All right. Thank you, Alex.